CDeL-505 Business-Statistics-Module 2 Data Presentation Techniques. Module Overview. Data presentation is an essential part of statistics. This is so because raw and processed statistical outputs are shown following formats that are acceptable enough to allow for proper consumption and comprehension. Having established the meaning of statistics and the underlying concepts, including establishment of the definitional and classification issues concerning data, it is now expedient for us to have a look at the appropriate tools and techniques that are employed in presenting data. This module is divided into 4 units, which are listed thus. Study Session 1, Tabulation, Diagrams and Charts. Study Session 2, Measurements of Location and Measures of Dispersion and Shape. Study Session 1, Tabulation, Diagrams and Charts. The expected duration of this study session is 1 week. Introduction. In statistics, data sets are expected to be presented in comprehensive and comprehensible manners. Some of the most commonly used presentation tools are tables, graphs, charts, and other statistical drawings. These are essential parts of statistical presentations, which not only make the presented information detailed, but also appeal to the eyes as they are quite analytical. In this unit, you will be exposed to these tools for statistical presentation, as well as how they are prepared and used. As you proceed in this unit, you will learn about 1. Tables and tabulation, 2. Charts, and 3. Graphs. Learning outcomes of Session 2. When you have studied this unit, you should be able to 1. Define and use correctly all the keywords printed in bold in your online study manual. 2. Identify tables and ascertain how to prepare them. And 3. Recognize the various forms of charts and differentiate them. Tables and tabulation. You can agree with me that tabulation is coined from table. It can be said that the process of making a table is tabulation. Then you would ask, what is a table? It is not the upholstery table in your sitting room, rather a table that has a different contextual and functional meaning. In its simplest form, a table can be seen as a statistical tool that presents data or information in rows and columns. As can be seen in Figure 1 in your core study manual, the vertical section of a table is called a column, while the horizontal section is called a row. In making a good statistical table, apart from the fact that you must clearly show the rows and columns, you must give attention to the following essential elements. 1. The table must be properly titled and subheadings used where necessary. You should understand the difference between the title of a table and the subheading. While the title represents the overall information in the table, which must be catchy and smartly captured, the subheading represents the heading of other sub-information in the table, may be the title of a row or column. The table should also have units of measurements, which are the denominators for the data captured in the table. It will be wrong if you write 1,000 when it's actually 1,000 kilograms. The difference between 1,000 and 1,000 kilograms is the kg, which is described as the unit of measurement. There should also be a source note at the foot of the table. You may wonder what a source note is. It is an indicator or acknowledgement of the source of information in the table. It is important to add source notes, especially for information drawn from a pre-existing source. Failure, which it can be said that an offense called plagiarism has been committed. Box 1.1. Uses of tables. Tables are useful in statistical presentation in the following ways. 1. Tables allow for easy comprehension of data. 2. It is easy to compress high-volume data into tables in concise form. 3. Tables allow for comparison of data, especially inter-period and cross-section data. 4. Data presented in tables can further aid statistical estimations such as mean, median, and other statistical averages. 5. Tables also present values that can be deployed in plotting graphs, constructing charts, and pictographs. As you can see, tables form essential parts of statistical estimations. A practical illustration of a well-constructed table is shown in Table 1, which depicts the gross domestic product and selected financial deepening indicators from 2010 to 2017. This is shown in your online course study manual. Activity 1.1. The time allowed for this activity is 1 hour. With emphasis on our discussion on the essentials of a good table, identify and write down those essentials as contained in Table 1 in your online course study manual. Charts. You may have heard or seen a chart regardless the kind. What makes charts stand out is not just the pictorial appeal, but the fact that it conveys or represents data. Technically, you may see as a statistical drawing or sketch that is in representation of data or information. Charts are of various nature, but for the purpose of this course, we shall give attention to the following very common types of chart: bar charts, pie charts, and pictograms. Bar charts. As the name suggests, we take a bar chart to be a chart that represents data using rectangular bars whose heights correspond with the magnitude of the data they represent. The three variants of a bar graph, as it is alternatively called, are 1. A simple bar chart, 2. Component bar chart, and 3. Multiple bar chart. As you see from Figure 2 in your course study manual, a simple bar chart shows just a piece of information tied to a particular constant, and one standalone bar is used in a manner that the height of the rectangular bar shows the size of data it stands for. You can notice that country Z has the highest population of 40,000 as shown by the height of its bar. However, when you have more than a variable tied to a constant, it becomes difficult for the simple bar chart to duly represent the data. This makes a case for the component and multiple type of bar chart. Multiple bar chart and component bar charts are contiguous in terms of purpose, but vary in terms of form. As you can see from Figure 3 in your course study manual, a component bar chart is one bar broken into components to illustrate different pieces of information relating to a constant. Can you see UBA and the three different classes of assets shown in the same bar at a time? That is what a component bar chart helps us achieve. You can as well see at the foot of the chart what is called identification key, marked in different colors. It helps us to identify what information each of the components represents. Having seen a component bar chart in Figure 3, take a good look at Figure 4 in your course study manual. Can you identify the similarities and differences that it shares with Figure 3? Okay, let us attempt drawing a dividing line between the two while also showing their similarities. In terms of similarity, both of them are useful in showing various information tied to a constant, as you can clearly see that the same data sets can comfortably be presented by either of the two. Conversely, multiple bar charts differs from the component bar chart as it deploys more than one bar to show the various information which component bar charts shows in one but stratified bar. Pie chart. You are aware of what is called a circle, and the fact that sectors of a circle have degrees equivalent to their sizes. More so, you are aware that the aggregate degrees in a circle is 360 degrees. A chart that puts information in a circle after converting them to their degree equivalent is called a pie chart. In making a pie chart, you firstly put the data in their degrees equivalent and delineate the circle to sectors in proportion to the magnitude of data that each of the sectors stand for. The sectors are then labeled to show the information they respectively represent. As can be seen from Figure 5 in your course study manual, which depicts quarterly profits of a small firm in millions of naira, the quarter with the highest profit volume is quarter 1. That is the reason for allotting the biggest sector of the pie chart to it. Pictogram. Is there any familiar thing that pictogram sounds like? I am sure you are saying pictures right there where you are. True to your guess, pictogram or pictograph is derived from pictures. Simply put, it is the representation of statistical information in pictures. Figure 6 in your course study manual is a pictogram illustrating student population in country Abego. Question. You have gone over the discussions on basic forms of charts. What do you think are the importance of using the statistical tools? Answer. They are illustrative and analytical. They appeal to the eyes, hence are comprehensible. They do not require extensive knowledge of statistics to use them. Their usage has mass appeal. Session summary. Undoubtedly, you must have learned a thing or two, which includes an understanding of the meaning of charts and tables and the key issues underlying them. Pointedly, you saw the meaning in how to make tables, bar charts, including simple, multiple, and components, and pictograms. Self-assessment questions, SAQs for Unit 1. Based on the foregoing, you are expected to address the following self-assessment questions, or SAQs. SAQ 1.1. You can identify and define the keywords in bold as seen in your course study manual. SAQ 1.2. Define a table and state the essentials of a valid table. Also, construct a table showing all these attributes. SAQ 1.3. Tabulate at least 3 key differences among bar charts, pictograms, and pie charts. Study Session 2. Measures of location and measures of dispersion. The expected duration of this study session is 1 week. Introduction. Basic descriptive statistics are largely broken down into measures of location and measures of dispersion. These averages are estimates that show the basic properties of datasets that are to be employed in statistical estimations. More to showing data characteristics, basic descriptive statistics can also be used for making inferences about the aggregative tendencies, spread, and variation of the distribution under focus. The importance of these elements in statistics justifies the need for you to be exposed to them. As you proceed in this unit, you will learn about 1. Measures of central tendency, mean, mode, and median. Measures of dispersion, range, mean deviation, variance, and standard deviation. Learning outcomes of Session 2. When you have studied this unit, you should be able to 1. Calculate such measures of central tendency as mean, median, mode, and others. Calculate measures of dispersion as range, mean deviation, variance, standard deviation, and others. Measures of central tendency. In your secondary school days, sitting in statistics classes, which of course was done as a topic in mathematics, you must have heard of measures of central tendency. Though right now you may have a faint recollection of what was said back then, one certain thing is that it was taught. Now, if there are 3 boys standing before you with 11, 12, and 13 as their respective ages in years, simple arithmetic average will place their average age at 12 years. That is, 11 plus 12 plus 13, all divided by 3. What does 12 mean to you as a decision maker? It sure would give you an idea that the youngest person will not be too less than 12, and the oldest not too far above 12. It implies that the age bracket hovers around 12. You should see the above as an example of what measures of central tendency help us achieve in statistical analysis. Measures of central tendency consist of those averages that show how close observations in a given distribution are. They are indicators of the aggregative tendencies or how close-knit a distribution is. I will not be amazed if you know the commonest measures of central tendency are mean, median, and mode. Guess I am right. Okay, we're going to look at these common aggregate averages as well as how they are estimated and interpreted. Mean. Get a sheet of paper. Write down a definition of mean and compare it to what I am going to say to you shortly as a definition of mean. If you are ready, see mine below. Mean is simply the arithmetic average of a given distribution. How right was what you wrote as directed? If right, congratulations. If not, I believe you must have corrected yourself looking at the definition I just gave. You may have noticed that the mean is one of the most common averages in statistical estimation. There are several variants of the mean and several circumstances under which it is estimated using formulae that are consistent with respective cases. Let us see how the mean can be calculated. Mean of ungrouped data. Ungrouped data are datasets not arranged according to class or frequency. They are just data gathered and not grouped, as you can see from the name. You can see the formula for the mean of ungrouped data in your course study manual. Mean of observation is equal to the sum of all the observations divided by the number of the observations or sample size. Let us demonstrate the use of the formula in your online course study manual using the following question. Question. In a certain class, a physics test was conducted for 10 students and the following scores recorded: 15, 40, 55, 60, 77, 40, 30, 10, 2, and 60. What is the mean score? Answer. In getting the mean score, you must first remember that the above illustration is a clear case of ungrouped data, and the formula to apply is the mean of the set of observations is equal to the sum of all the observations divided by the number of the observations or sample size. So, our n, that is, number of observation or sample size, is 10, and our sum of all the observations will be 15 plus 40 plus 55 plus 60 plus 77 plus 40 plus 30 plus 10 plus 2 plus 60, which is equal to 389. Hence, the mean of the set of observations is equal to 389 divided by 10, which is equal to 38.9. Can you see that it is not difficult to estimate the mean of an ungrouped data? Create a scenario such as the question just asked and try your ability in replicating what we just did. This will help strengthen your understanding. Mean of a group data. In determining the mean of a group data, we will be looking at 3 different circumstances. 1. Mean of a group data from a frequency table. 2. Mean of a group data with a class interval. And 3. Mean of a group data using an assumed mean. We will show how these various forms of mean are estimated in the following questions and answer. Question. This question illustrates the estimation of mean of a group data from a frequency table. 40 drivers left Lagos from Enugu in Nigeria on a certain Monday evening. These figures represent the number of hours it took them respectively to get to Lagos. 5, 6, 6, 6, 7, 8, 9, 10, 11, 6, 6, 7, 9, 5, 10, 12, 11, 13, 7, 6, 8, 9, 14, 12, 10, 10, 6, 7, 5, 6, 7, 7, 13, 15, 10, 11, 12, 13, 10, 6. See the question in your online course study manual. Prepare a frequency table from this information and determine the mean travel hour. Answer. In addressing a problem like this one, you should first know that it involves the determination of a mean of group data from a frequency table. Also, you should take note of the formula for finding a mean in this circumstance, which is stated thus. The mean of the set of observation is the sum of the number of occurrences of a given observation times the number of observations divided by the sum of occurrences of a given observation. That is, the mean is equal to the sum of f times x over the sum of x. See your online course study manual for the formula. Comparing this formula with that of an ungrouped data, you will notice that the newest introduction is the letter F, which stands for frequency and is defined as the number of occurrences of a given observation. We will begin by constructing a frequency table. See your online course study manual for the cumulative frequency table. Note that the cumulative frequency column shown in your online course study manual is a successive addition of the number of occurrences of each of the observations x, while fx is frequency multiplied by the number of observations. You can see the sum of the f and fx. Putting this into the formula will appear thus. The mean of the set of observations is equal to 351 divided by 40, which is equal to 8.775, or approximately 9 hours to the nearest 1 hour. Was that complex? I guess it was not, though a bit tougher than that of ungrouped data. It is, however, suitable when a large array of data is involved. The next question illustrates the estimation of mean with a group data with class interval. To show the second form of estimation of mean of group data, that mean of a group data in the face of class interval, we deploy the example in question 2.2 in your online course study manual, assuming a class mark of 3. You should take this class mark to be the number of observations in a class interval. Answer. This follows the formula for group data on a frequency table, but as you can see from the table in your course study manual, there is a grouping of the observations in a manner that each of them falls into a class. You should also notice a new column titled Class Mark, which is the sum of the lower class boundary and the upper class boundary divided by 2. For example, 6 as the class mark for the 5 to 7 class is obtained thus: 5 plus 7 all divided by 2, which is equal to 6. Therefore, the mean for the set of observations is equal to 345 divided by 40, which is equal to 8.625, which is approximately 9 hours to the nearest hour. Whoa, it's amazing that the two methods produced the same result relatively. Remember, we still have the third method, which is the determination of the mean of a group data using an assumed mean. The next question illustrates the estimation of mean of a group data using an assumed mean. Question: in using an assumed mean, a rough look is made at the observation and certain base level common to all of them is ascertained so that the real mean now becomes the assumed mean plus the mean of the deviation from the assumed mean. The underlying view for the use of assumed mean is that if x subscript 1 is equal to d subscript 2 plus a, and x subscript 2 is equal to d subscript 2 plus a, and x subscript 3 is equal to d subscript 3 plus a, therefore xi is equal to di plus a, where d is deviation from the assumed mean a. In case of the group data, the real mean is given as a plus sum of f d over sum of f. Let us now apply the above method described to find the mean using an assumed mean of 5. See the table in your course study manual for more explanation. Just for a moment, remember that the formula for the mean is equal to a plus the sum of fd divided by the sum of f, where a is equal to 5, the sum of f is equal to 40, and the sum of fd is equal to 145. Substituting, we will have your mean is equal to 5 plus 145 divided by 40, and this will be 5 plus 3.625, making the real mean 8.625, which is like the other two methods, giving 9 hours to the nearest hour. You can agree wholly with me that the three methods show consistency in terms of their outputs. Which of these three is your preferred option? Of course, you are to get conversant with all three, as you may be tested on any of them. Median. Unlike the mean that is an aggregative average, the median is a positional average. You may ask how. What qualifies an observation as the median is the position it occupies? In precise terms, the median is the observation in the middle when the distribution is arranged in descending or ascending order of magnitude. When the number of observations is odd, it is easy for one observation to clearly be at the middle. What if the number of observations is even? How do we determine the middle observation, you may ask? In a circumstance such as that, the median becomes the mean of the two middle observations. Usually, the median is the observation that is the n plus 1 over 2 observation. Question. Find the median score of the following scores recorded for a pre-MBA class test on statistics: 2, 6, 3, 4, 9, 7, 8, 9. What if there was a student previously omitted but now added with a score of 3? What will the median be? Answer 1. Firstly, you will rearrange the values in order of magnitude thus: 2, 3, 4, 6, 7, 8, 9. You can tell clearly that the number in the middle is 6, hence the median is 6. With the inclusion of the omitted score 3, the observations will appear thus: 2, 3, 3, 4, 6, 7, 8, 9. With these, there will be no single value in the middle, but 4 and 6 become the two middle observations, and 5 becomes the mean of 6 and 4, hence the median is 5. We have just handled the two likely scenarios with ungrouped data. You may begin to think, what of grouped data? I am sure you have not forgotten the difference between grouped and ungrouped data. Median of a group data. Like the mean of group data earlier discussed, for a straight frequency table, it is easy to isolate the median through the cumulative frequency. For a group data with class interval, the median is given using the equation in your core study manual. In that equation, L1 is the lower class boundary of the median class, N is the total frequency or number of observations. Sum of F1 is the sum of all frequency lower than the median class. F median is the frequency of the median class. C is the size of the median class interval. You should know that the above process is the determination of the median through interpolation. See additional illustrations in your core study manual. Mode. This is the measure of central tendency that represents the most popular member of a given distribution. You can put it this way: the mode is the most frequent member or observation in a given distribution. In an ungrouped data, it is just easy by account to determine the mode. Some distributions may be unimodal when it has one mode, bimodal when it has two modes, trimodal for 3, and so on. For example, the list of observations I will describe will have 3 as a mode, and it is also considered unimodal. 2, 3, 3, 4, 6, 7, 8, 9. In the case of a group data, the mode is determined through an interpolation process like the median above, using the formula in your core study manual. In this formula, L1 is the lower class boundary of the modal class. Changing 1 is excess of modal frequency over the next lower class. Changing 2 is excess of modal frequency over frequency of the next higher class. C is equal to the size of the modal class. Question: find the mode from the table in your core study manual. Answer: we apply the mode interpolation formula. You should know that the modal class is the class with the highest frequency, but we want to identify the specific observation that is the modal observation. Therefore, mode will equal to 5 plus, in parentheses, 18 divided by 18 plus 7 times 3. Therefore, the mode is equal to 5 plus 2.16, which is equal to 7.16, which is approximately 7. Following the interpolation formula, 7 is the mode. Measures of dispersion. Earlier, we looked at measures of central tendency, which are indicators of how close-knit observations are. Another perspective of descriptive statistics you need to know would be the spread and variability properties of the series. Measures of dispersion show how far apart the observations are to themselves. You will be exposed to the following prominent measures of dispersion: range, mean deviation, variance, standard deviation. The range of a distribution is the difference between the lowest and highest observation in a given distribution. You can agree with me that this is a measure of spread between the minimum and maximum observation. So, in a distribution with the following observations: 1, 2, 3, 4, 6, 7, 8, 3, 2, the range will be 8 minus 1, which is equal to 7. Mean deviation. Mean deviation can be defined as the mean of the absolute values of the deviations from the mean of a given distribution. Absolute values of deviations means taking every deviation as positive, regardless of their signs. For ungrouped data, the mean deviation is given as the formula shown in your online core study. where mean deviation is equal to the sum of observations minus mean divided by the number of observations. In the case of group data, mean deviation becomes the sum of F bracket observations minus mean divided by the sum of F, where F is equal to frequency. Using these illustrations, mean deviation will be calculated creating the frequency table shown in your course study manual. Please refer to your course study manual at this time. Based on the frequency table you have just referred to, the mean deviation is equal to 97/40, which is equal to 2.427. It is common knowledge that the mean deviation does not enjoy too much popularity. This is due to a major flaw that it has. This is the fact that the conversion of negative deviation to positive by making them absolute values has no plausible mathematical basis. Variance and standard deviation. You will recall from the discussions on mean deviations that the process of elimination of negative deviation makes the process and products less acceptable. To properly deal with this challenge, the variance process squares the deviation to appropriately remove negative deviation. While the mean of the sum of the squared deviation becomes the variance, the square root of the variance becomes the standard deviation. Do not forget that the variance and standard deviation are among the most acceptable measures of dispersion. Estimation of variance and standard deviation. The variance for an ungrouped data is given in your course study manual. Variance is equal to the sum of the number of observations minus the calculated mean of the distribution squared divided by the number of observations. Remember that when we said that the square root of the variance is standard deviation, the formula for the standard deviation of an ungrouped distribution is shown in your course study manual, and it is simply the square root of the variance. Question. A group of market women bought bags of Gary for resale and recorded the following profit in Naira per bag of Gary sold: 12, 10, 16, 30, 22, 8, 6, 15, 13, 15. Determine the variance and the standard deviation of the profit recorded. Answer. To determine the variance and standard deviation, we will firstly find the mean, which is the sum of values divided by the number of observations, which is equal to 147 divided by 10, which is equal to 14.7. The variance will be the mean of the squared deviation, which will equal to 447.7 divided by 10, which is equal to 44.7. The standard deviation will be the square root of the variance, which is equal to the square root of 44.7, which is equal to 6.69. The steps to calculate your answer can be found in your course study manual. In case of a group data, the variance and standard deviation can be estimated using the formula shown in your course study manual. Question. See the table in your course study manual for this question. The table shows the score charts of students in a given examination. From that table, determine A, the mean score, 2, the variance of the score, C, the standard deviation. To get the mean, variance, and standard deviation, you should recall that there is need to build a frequency table, which is shown in your course study manual. Having created the frequency table with all the parameters needed, let us now find the mean, variance, and standard deviation as follows. The mean is equal to 4,325 divided by 100, which is equal to 43.25. The variance becomes 302,825 divided by 100 minus, in parentheses, 4,325 divided by 100 square, which is equal to 1157.6875. the standard deviation becomes the square root of the variance, which is equal to the square root of 1157.6875, which is equal to 34.02 approximately. All calculations and steps are clearly shown in your course study manual. Please refer to your course study manual. Activity. Aside the methods we have demonstrated, you can strengthen your knowledge base by going through some books on statistics and making discoveries on other possible estimation processes and formulae that can be employed in determining mean deviation, variance, standard deviation, and others. Session summary. It has been a long one, hasn't it? Evidently, you must have learned a thing or two, which includes, but is not restricted to, meaning and estimation processes for measures of central tendency, meaning and estimation processes for measures of dispersion. Self-assessment questions for Session 2. Based on the foregoing, you are expected to address the following self-assessment questions, or SAQs. SAQ 2.1. Using the data set below, calculate the mean, mode, and median of the distribution 2, 4, 6, 8, 10, 12, 13, 14, 15, 20. SAQ 2.2. Referring to the table in your online course study manual, which shows the value of annual income of households in a given community, determine A. the mean income, B. the variance of the mean income, C. the standard deviation. See your online course study manual for further reading.